Now, yes, thank you for the good tip. I was just saying we are Aucotec and we will show you the product engineering base. This is our agenda today. I will start with a short introduction and then Henry will show you a slide deck with focus on disk and how engineering base can be useful for solving challenges within all these four elements: digitalization, industrialization, standardization, and collaboration. And then Benham will show you a live demonstration directly inside engineering base. Yes, so my name is Anders Høie. I'm a key account manager for Aucotec Norway, and my main focus is to help Norwegian oil and gas companies succeed with engineering base. I am Norwegian from Haugesund, and I lived several years in Stavanger, and now I'm based at Fornebu. And Henry and Benham are both from Germany. Henry is a product manager, and Benham is an application consultant. Some facts about Aucotec. We are a German company founded in Hanover in 1985, and we have subsidiaries in some big countries like US, China, and India, and we are represented all over Europe, including Norway. We are more than 240 employees, and we have a healthy economy. I think one beautiful thing with Aucotec is we have this combination of a good old German structure, and at the same time, we are this international, exciting technology company. So the perfect balance between stability and growth. And our main focus by far is the product engineering base. We have more than 100 engineers and developers working on all the aspects of engineering base. And process plans is a really strategical focus for Aucotec. You can see some of our references to the right. And for Aucotec, it's always an important goal to build long-term and trustful partnerships with our users. And now Henry and Benham will show you more about engineering base.
Yeah, thank you, Anders. Warm welcome also from my side, Henry Bloch, Product Management. So I want to start with digitalization. And from our point, digitalization only works with data. Data is the key in digitalization. And if we have a look on the left-hand side on how other toolings are maybe working, then you will have different tools, A, B, C, D, and so on, and maybe until Z, for all of the different technical tasks that you need to fulfill during engineering. Some of them are somehow connected to something like a file storage system, but it's really a big challenge to keep all the data synchronized. This is why the overall idea of engineering base, as you can see it on the right-hand side, is to have one central database. It is one central database. You have your asset one time real in the plant or platform, and you have it one time in the database. You have different views on it, as you can see on the top, different representations in the different diagrams, but we have a single source of truth. We do not have the same data at two different points in the system. It just doesn't make any sense. We have to keep it clear at one single point. If we look into our data model, then you could start in the feed phase of your engineering with our processes. So to state your scenarios or states of your plant or platform. And from there, you could go on and define the functional view of it, or the functions within the platform. We call it the systems folder. And from there, it goes to the real equipment, so the real physical assets or the device representation. And you see these dotted lines in between. These are relations. We call them associations, so that we have, for example, in the process of operation, the motor of the pump, which is also in the function of a PCE loop. By this, we bring more value to the data because we connect the different aspects of it. We don't want to use the document-centric way anymore. We are fully data-centric. The next aspect on this is areas. So where is this device located? And this whole structure follows the IEC 81346 standard that defines exactly this way of how you structure plans. Out of this, you can then have all the different diagrams, lists, reports, and so on. And all of this together is engineering base. And I have to point this out again. you will find the data only once in the database, the real data, but you will find the representation of the data in all the documents, diagrams, and so on. So that is for D. Now let's move on to I, industrialization. Therefore, we want to show you how we work in the industry, and we have the example here with the Equinor Spine project where engineering base is used. The scope of Spine and EB together was to establish a facility asset model, to have data available independent of the source. And engineering base was established, or the scope was to establish engineering base for storing and maintaining structured LCI data. This data structure for FAM and as-built data in EB are all based on industrial standards. And we want to expand the LCI solution to cover more structured data and improve work processes. You can see on the right-hand side the different silos from where the data is coming. And one of them is engineering base for all the engineering data to bring it into the overall environment. Equinor is implementing engineering base of the part of the FAM and as the single source of truth for engineering data. So all the engineering data in this this environment is stored in engineering base. EB is, or sometimes we make engineering base short, and it's EB. EB is well suited to support this, as it is really not anymore document centric. It is not unstructured documents. We are structured data. So no documents, not unstructured, but data and structured. That is the core of engineering base. The overall concept is well fitting to build this up. And in the end, the users can then use our client, as you can see on the screenshot here, to maintain and to query the different data of all the engineering data in FAM. And we have also the implementation phase started to have interfaces to FAM, to publish data to other applications, and to the TIE portal. Let's move on. D and I are covered. Let's move on to S in disk. This is standardization. I can assure you that one of the main activities and strategic activities of Aucotec is to support relevant standards. I just listed a few that we have implemented, and I want to point out a few of them. So if we point out CAEX, which is the basis of automation ML, we implemented both of them, and the AML import was also the starting point of our work with Equinor. And then on the right-hand side, CIFOS. We are highly active in the CIFOS organization and standardization, also according to JIP 33. And you can see on our booth how we implemented JIP 33 datasheets. 2 weeks ago, I presented, we presented at NAMO General Assembly in Germany, how to use OPCOA to connect live runtime data to engineering base and update your documentation out of it. So if you switch a sensor from one vendor to the other in the night shift, then you don't have to go there and read the documentation of the night shift anymore. You click a button and you have as-built data in your plant. We are also active in DEXP, which I think you're all very familiar with, and also one of the founding members of the DEXP Association, founded recently. Also in E-Class, CIFOS, Open Industry 4.0 Alliance, and USPI. And now let's move on to C for collaboration. And maybe this is not the start that you expect when we talk about collaboration, to show you our architecture. But from our point of view, only if you have a modern architecture, you can really do collaboration on top of it. So our architecture is tier 3 with the data layer at bottom, where you can import by high-speed importers XML data. Also examples for DEXP can be imported. On top, we have the business logic running an application service. And here we can import various data formats. Also, the Excel files we received last Thursday are imported, and you can see this on our booth. Also, Automation ML, WGG, XML. On top are the rich clients and the data service, data as a service. So we have open APIs, and we have, by this, different possibilities to integrate engineering base into other tooling as well. Talking about the integration, we have different integrations available to predictive maintenance tools, to ERP systems like SAP. We have a mobile application where you can view into the database, electronic signatures tooling, simulation tooling, AspenTech and ETAP, for example, 3D design and automation in DCS. And all because what you see on the right-hand side, because we have an open API and web service technology that also allows you to do your own integrations. So this is DISC on PowerPoint level. Let's see one last point in it. This is the features that you need for collaboration. I pointed out or brought here 4 different features I want to point your attention to. The first one is the change management, version and revision management, so that you have always a clear understanding which is the release document, what is the current revision. You can do this in Engineering Base. Task management. Tasks are data objects in Engineering Base. So you can bring associations from tasks to equipment, to functions, so that you always know what is really included. On diagrams, you can highlight them, so you know what to do, what is affected. We have an object history for every data object. By this we know who did what, when, and why to an object. This is highly, highly, highly important. If you do collaboration worldwide, different time zones, no chance to have a meeting together, then you have an object history that includes all of the information that you need to know, why an object was changed and what was the change. And last but not least, the data tracking. Data tracking allows you to have a look what is new data, what is modified data, and what kind of data has been deleted. So this is just a few of the features that we have. The other ones I would like to give the word in a minute to Benham to show it in a live demo. We will show in the live demonstration how we will import the DXB file to Engineering Base, see the drawing and the data model, see how the data tracking works in it, the object history, and how we can export it again. And we also use the verification tool of DXB, of PNB, to show then how the result is. And for that, I will give the word to Benham.
Thank you very much, Henry. So, what you will now see in the live demonstration is nothing that is furbished or preset or set up in advance to give you a nice and fancy result. Okay, yeah, I see that. You will get the naked truth. So even here, some technical issues can happen always in a live demonstration. Perfect, thanks. And let's see. Oh, I don't think that it worked like this, since I will not see my own screen. Maybe like this. Now it works. All right. So let's jump right away into the application. So what you see here is the user interface of our solution of Engineering Base, or in a short term, EB. We have different views onto the information in the database. So right now, this is the view on a folder with different projects. This is an example project that will be relevant for the demonstration now. So I can focus on that project specifically. So the look and feel is similar to Microsoft products. It is not Microsoft product, but look and feel is similar. So it is basically an empty project. We are, what Henry also already mentioned, we are according to the ISO standard 81346, which means we have the different aspects of a plant, of a system, and equipment, systems, areas, so and further system specific folders here. And as you can see, it is it is empty. So this will change in a moment. And therefore we will use the worksheets in Engineering Base in EB, which give us the possibility to basically visualize and to show any information in the database in a list form. We can run queries and search for different information. We can even export it to an Excel file format to use it, for example, for data exchange for subcontractors, etc., and re-import it and have our database consistent. As you can see, there are no objects right now. This will change in a second when we run the first DEXP import based on the blueprint file. So this is our DEXP assistant. We have the chance, which we will see later on, to choose between the import and export. Right now, for us, it's important, or let's say we will start with the import, of course, to get in some data. This is the basic blueprint file that we received, or also using in the Spine project, coming from the DEXP group, prepared by PNB. So this will be the basis for our import. And as you will see, the structure in our data model, in our database, will change immediately when I press import. You will see that the objects are coming in. So it will be filled even with structures. So we have here defined folders where the equipment will land. We have the system aspect that will be filled according to the information inside of the DEXP file, and that is an important point. So we can only get the information in that is based on the file that is to be imported. So import already finished. So just to show you the content, I mean, you have already seen it several times. That is an SVG file of the blueprint. So that is how it looks like. And this is the result that we get in EB, as mentioned. So we can run certain queries. Let's say I'm looking for a specific tag here. I can also use wildcards, and I will find that object. So it's not an ordinary and simple worksheet that is here, that we see here. I can even, that is again single source of truth. I will try to emphasize a lot of times during the presentation, because the information that is given, or that we see here, the source is always the same. So I can navigate directly to this recently imported object, which is the manual valve. Let's close this one. And beneath, we already have a structure. So the relationships that Henry mentioned, we have different kinds of. We have associations, we have aggregations, kind of a parent-child relationship, and we can also see, for example, here we can see this is also. I will, in parallel, by the way, I will refer to the points that are relevant regarding scoring. It's not so important for us, but of course that is also something that I will do in parallel. That is a viewer in this case, so I will see the reference to the manual valve here, the special valve on the PIN-ID. I cannot change anything here, but we have other options to do that. There's also relationship and association to a pipeline, because it's a piping component. It usually is part of any pipe segment. I can navigate again here directly to the pipeline. And here with the pipeline, this is a segment, the respective objects, inter alia, the valve that I just have that we just saw, is associated. That is also according to the requirements and setup of your system. So in that case, it is associated, it's not aggregated, but we have also aggregations, for example, this orifice plate and the reducer, which are aggregated directly to the pipeline segment. Again, here we have the reference to the PIN-ID itself, which is already imported. I will come to that in a second. We have the system aspect, but when it comes to change management, that is also something that Henry mentioned. We have data tracking, so I can now have a look on the data tracking compared to my current project. There are different snapshots that you can create during your engineering, as we can see, all the objects, because it was basically an empty project, are coming in here. So I can, again, here I can, even from here I can navigate directly to one specific object, or even directly open the pin ID. The object itself will be highlighted, and this is, again, this is related to Microsoft. This is Microsoft Visio based. So this is our graphical engine, but it's not an ordinary one. So we have access to the complete database, as you can see here. And I will now do a small change on a designation of a pipe. So maybe even before, I will do it on different levels. So this is our worksheet. I have even on a graphical, let's navigate here first in the tree so that we can see the changes everywhere. And again, to emphasize for the single source of truth, I will open the attribute set of this object and we'll do a small change here. Just change the designation and let's say the nominal size of the pipeline. And in the moment when I press OK, you will see everywhere this information is used, it is already changed. It's already updated. So even in our worksheet, as we can see here, it is already changed. So regarding change management, a further option that we saw on the slides before is the object history, that I can also access directly from the graphical engine. We can see all the changes. So depending if you want to have it user specific, timestamp, this is all flexible as basically everything in Engineering Base. We can see the changes with an old value, with a new value, and that's the way how you would treat the changes, or at least could track the changes related to one specific object. All right. So now we will create a new snapshot. To show you the difference of the snapshots and to have different scenarios. For that I will, and that is, I think today we haven't seen that so far. The blueprint is not only the blueprint, it's not only the basic blueprint. We have been provided, or there have been provided different blueprint versions. So in that case, we have already imported the basic one. Now I will have, and I will show you what the changes are. We will have the import of an adapted, so the showcase or the scenario is that you get an updated file that you will import into your system, how the system will treat that data. And it is a small change, but nevertheless we can see that here there is a new segment and a new object, a new valve here that hasn't been there before. That is the basis for our second import. So we can now choose between the different snapshots. So we can compare it to the current project. We can even compare it to a previous created snapshot. We will compare it to our current project, and we will see that there are new objects. Of course, it depends. The result that you receive here is depending on the snapshots that you take as a comparison. And there's one specific new equipment, that is a valve that we just saw, which doesn't have a designation. We can directly from here, of course, let's show you the updated data model tree, and I can also from here, I can jump directly to the pin ID, and it's already updated. It's highlighted by the system. I could now change the designation, but I think that is something that you already have seen, that I already showed. So let's come to the export. So how does the export look like? And I have to say that so far the focus was also as part of the Spine project. The focus was the import. So we developed or put our work mainly into the development of the import. But I think we have also a pretty good solution for the export, but you can make your own, you can see on your own. And for the export, as mentioned before, we will use the verificator from PNB. So as you can see, this is not an Aucotec specific tool. It is coming from the DXP group. So this is just, yes, that's the right one. And this is the result that we already received. Again, please keep in mind that we just recently started the development of our export, and this is already the outcome of the content. Everything again based on the blueprint. Okay, so far.
All right, Benham, thank you very much for the live demonstration. Let's switch back to PowerPoint to give a short summary.
Yep, I think it's this one.
Perfect. So let's summarize this. I think you've seen that Engineering Base is a cooperative engineering platform, that the basis is the modern architecture, and collaboration features and standardizations are key features of Engineering Base. We think we ticked all the boxes except for PDF import. Right now we can store PDF into our data model, but we cannot read out all of the data out of it. But we have ongoing research with that in the direction of AI to cover all of the data also there. But currently, this is most probably something we cannot tick today. Maybe half a tick that we can store it, something like that. So join us at our booth and convince yourself of everything that you may want to see in detail. But before you give us the applause, we have one more thing to show you. We all have heard about IMF. And we just recently also are able now to work on IMF. As you know, IMF is available online and file-based, as you see on the right-hand side. We can use this, bring it into EB as library objects, and then it is there, the data applicable for all EB functionalities, via online or via the file-based. And I don't trust myself either in PowerPoint, so I will hand back the microphone to Benham to show it live.
Speeding up things, since we don't have not too much time left. So, yes, IMF, big topic. Again, let's have a focus on this one. This can be a catalog project. As we can see, again, we have the different aspects of a plant. We have already some objects integrated, but let's say we want to update and see if there are any, if there's any new further content. So, right, here we go. This is our assistant, and currently we are live connected to the PCA IMF library, as we can see here down below with the green light here. So I can now choose from different libraries that are existing in the IMF RDL. Let's take this one, and let's synchronize it. Let's have a look also on the data set that is already inside. You will push the button and you will see that it will be updated. And not only the new or not already synchronized and existing ones, as for example, the control valve product, control valve function is now included in our library, in our catalog. Even the already existing ones, according to what we have selected here in our from the library, it will be updated according to the information that is available on the PCA RDL. So that is the live way to do it. We can even do it with in a manual way, since there has been provided data provided in advance. So JSON files in that case, we are even able to import them in parallel. So let's take this process heater product IMF, and you will see that this will fly in as well. So both solutions depends on how you want to work, on how you want to integrate IMF data in this regard.
Yeah, just one last word. Thank you, Benham. So you've seen that's working. We have a property and type mapping in the background for that. If you want to look any more detailed into it, come join us at the booth. We're 6 people from Aucotec here. We are all happy to talk to you, discuss the topics with you, and thank you very much for having us today.
And we have also solutions for the other parts. So all the other data that has been provided, we have solutions.
Thank you, Aucotec. Thank you. This is very solid, structured, and you adhere to the standards. Thank you so much. Any comments from the technical committee here? And amazing that you are actually six people and so many people joining in from Germany. Very good. Any comments?
Yes, of course, fantastic to see you are connected to the library service and show that it's working already. I can also a bit biased there, so I think I will share. Give Jan maybe.
Yeah, no, I'm impressed, and as Tonje said, this was rock solid, very very good. You handle the old way of working, and you are also pointing the way into the future, how we would like to work. Thank you very much.
Big applause to Aucotec.